Hi guys, welcome to another algebra video. So today, I introduce you guys about algebraic factorization. Algebraic factorization technique. Also problem solving. So, as you know that before I posted a video about how do you find a squared plus b squared and a is n plus b this and this is all factorization. So today let's do some problem solving, and then you guys know that you can do a lot with algebraic factorization to solve a lot of problems. My computer laggy, so I have a bad A rate. Sorry, so let's say that if x plus y is equal to 2 and x to the fourth plus y to the fourth is equal to 1,234, then find xy. So, as you know that this is not equal to x plus y to the fourth, and that's really obvious, right? So, we can just first try factor x plus y to the fourth power. And we know that this is basically equal to 16, right? And this, by binomial theorem, is equal to x to the fourth plus 4 choose 1 times x to the 3 x cubed times y plus 6 because 4 choose 2 is 6 times x squared times y squared plus 4 times x times y to the third times y cubed and plus y to the fourth power. So this is a complete expansion. And we know that this is basically 16 is basically just equal to 1,234 plus 4x cubed y plus 4 times x times y cubed and plus 6 times x squared y squared. That's it. So we just want to find that, and we know that this is basically just equal to negative 1218 as 218. Okay. Okay. So we're gonna play around with this. Now we have the key realization that x plus y squared is equal to x squared plus y squared plus 2xy. Okay, so we'll just use it. So first, let's take out 2xy to see what's gonna happen. Then we'll multiply everything, and this is just basically just x squared plus y squared plus 3xy, right? So, and then we can realize that if you divide this whole thing by 2, we will get 4xy times x squared plus y squared plus 3xy over 2, right? This is basically the factoring form. And then, but then we can realize that x squared plus y squared plus 2xy is equal to x plus y squared, right? So, we can rewrite this again. We can rewrite this as 4xy times x plus y squared minus xy over 2, right? Because you see that x squared plus y squared plus 3xy over 2 is basically just equal to x plus y squared minus xy over 2. So then we can just factor, and this whole thing is equal to negative 1218, by the way. Okay. So we just realized that this is basically 4. So we know that x plus y is equal to 2. So x plus y squared is equal to 4. So this is, so we just simplify this into 16xy minus these two cancel out. So minus x squared minus 2x squared y squared. We left it with a 2 and this is a 1. So it's 4xy times xy over 2. Then we'll just definitely 2 x squared y squared equal to negative 1218. And this is basically just equal to xy squared. So let's just do the exchange method. Let's set u is equal to, just say u is equal to xy, which means 16u, oh my god, 16u, this writing is so, 16u minus 2u squared is equal to negative 218. We're going to make it into a standard form. So it's negative 2u, negative 2u squared minus 16u equal to negative 1218. Okay, we multiply other side by negative 1, so we get 2u squared, this is plus 2u squared minus 16u equal to 1218. And then we get that basically 2u squared minus 16u minus 1218 is equal to 0. We take out a 2, right? So we take out a 2. So we get, which is 2 times u squared minus 8u minus 609 is equal to 0. So we can find u by factor this, and we factor this, we know that this is u minus 29 times u plus 21 is 0. So basically, u is just gonna be 29 or negative 21. This is our solution. Let's look at another more interesting problem that we're gonna even involve fractional factorization identities. Let's say that S be the sum of the real roots of polynomial f of x is equal to x to the fourth minus 21 times x cubed. Oh my gosh, this is so annoying. Minus 20 times x squared minus 21 x plus 1. And what we find, so S is going to be the sum of real root. So stop. And P equal to the product not real z's, not real zeros. Find S plus P. Okay. So how are we gonna find this? We can't. If it's basically saying if this is sum of real zeros, then we can basically just add. But this we can't because this is the product. So I'm gonna factor this a little bit, right? So we can divide the whole thing by 2. I'm gonna drag this down a little bit. So let's divide the whole thing by 2. Okay. Not 2, by x squared. So then we get x squared minus 21x. What's wrong with you? 21x minus 20 minus 1 minus 21 over x and plus 1 over x squared. This is equal to 0. So now let's set y is equal to x plus 1 over x. Okay, because these both sides are minus, so we're gonna just factor a little bit with this whole thing. Let's put it aside. Okay, so we now know that this whole thing, this x squared plus 1 over x squared is basically u squared, sorry, not u, y squared minus 2, right? And minus, and this is 21, negative 21x minus 21 over x is basically just subtract 21 times x plus 1 over x. So this is basically just 21u. Subtract 21u. And we have a rest of subtract 20 is equal to 0. Right? So this we get that y squared minus 21u minus 22 is equal to 0. We factor this, we get y minus 22 times y plus 1 is equal to 0. And y is the value of this. So then we're going to separate this. First case is x plus 1 over x x equal to 22. Then we multiply both sides by x. We get x squared plus 1 is equal to 22x. And subtract, we get x squared minus 22x plus 1 is equal to 0. And for now, we just want to check the quadratic formula if this is going to be real or imaginary. So first, negative b plus or minus square root. So this must all be real, okay? So the sum of the root is basically just, so we're going to target the sum of real zeros, which real zero is basically just negative b over a, which is equal to 22. And the second case is x plus 1 over x is equal to negative 1. Then we multiply both sides by x. X squared, so it's x squared plus x plus 1 is 0. And then we plug in the quadratic formula, which means all of them must be imaginary. Because negative b, so basically just 1 plus or minus, negative 1 plus or minus square root of 1 minus 4. So basically just equal to I times square root of 3, which is an imaginary number. So we just want to find the product, which is c over a, which is 1. So the answer is basically just equal to, so the solution is basically just 22 plus 1, which is equal to 23. Thank you for watching. Enjoy the content and see you next time.